Hello, I'm Atan Karabey from Electrical Engineering. Today I'm going to present my Physics 101 experiment, which is the compatibility of Hooke's law and simple harmonic motion. In this experiment, I'm going to try to take this spring constant from the Hooke's law and compare it with the spring constant that comes from the simple harmonic motion equation, the period equation. Yeah, let's get to the experiment. So, in this experiment, we will need three masses. Also, we will need a timer, of course. Then we will need a ruler and a spring. In the first part of my experiment, I will try to take the spring constant from the Hooke's law. For this, I need the force exerted on the spring and the displacement on the string caused by it. Spring constant is force divided by the displacement, and to find it more accurately, I will try this experiment 3 times with 20 grams, 40 grams and 50 grams masses. From these 3 experiments, I made a graph so that I can take the spring constant by taking the slope of this graph. From the first part of this experiment, I found the spring constant as 98 kilograms per second square. Let's take a look at the second part of this experiment. In the second part of my experiment, I will try to get the spring constant from the simple harmonic motion formula for the springs. In this formula, we need the period of oscillation and the mass of the whole system to be able to get the spring constant. To be able to get the half of a period, I stretched the spring and released it and timed it until it reached its maximum height. But I used 50 gram mass to be able to stretch the spring easier, and I also taped it with a slow motion camera, as it is very hard to see the time that it takes for the spring to reach its maximum height with raw eyes. I repeated this 5 times for accuracy, and I found the average of the 5 releases 5 times to be 0.10 seconds. To find the mass of the whole system, I added the mass of the 50 gram mass and the mass of the spring together. As a result, I found the spring constant in the second part as 82.21 and the error percentage as 16.7. All in all, it was a really small error percentage, as the human error can be really much in this experiment. So I say the spring constants that came from the two formulas are pretty compatible. Thank you for watching.